Welcome back to z/OS Introduction. This is the 22nd video in the series. Now that you have a better understanding of virtual storage and address spaces, the new learning objective is to describe the management of operating system and application program address spaces. An address space is a consecutive sequence of integer numbers, virtual addresses, together with the specific transformation parameters which allow each number to be associated with a byte location in storage. z/OS provides each user with a unique address space and maintains the distinction between the programs and the data belonging to each address space. While an address space includes system code as well as user code and data, all the available addresses are mapped. Some of the available addresses are mapped for system code, which is common to all user code and data. Given virtual storage addresses mapped to frame addresses and slot addresses, the big picture of address space management can be explained in the context of virtual storage addressability. Each address space is assigned addresses from 0 to some number n, where n is large enough to hold all the address page segments. Each address space includes private area for pages that belong to your program and common area for pages that belong to the operating system. Shown is a detailed z/OS layout of an address space consisting of private area and common area storage. The right side shows the total addressability amount. However, you might notice it is not to scale. The left side shows which addressable areas are private and common. The common area is loaded up with operating system pages containing specific services available to the private area application program. Extended private and extended common areas exist as a result of operating system 64-bit addressability advancement from previous generations of the operating system that had 31-bit addressability and 24-bit addressability. Observe the left side of the chart and the arrows on the chart. The arrows are showing that z/OS parameter customization can increase the size of private area addressability, which would reduce the size of the common area addressability. The need for this z/OS parameter adjustment is for the systems programmer to select a best mix for total number of operating system pages versus application program pages. This is a performance and capacity management exercise to optimize system efficiency. View z/OS address spaces as user runtime containers. A z/OS can run hundreds and even thousands of address spaces concurrently. System address spaces are started after initialization of the master scheduler. These address spaces perform functions for all other types of address spaces that start in z/OS. Middleware address spaces exist for major subsystems and middleware such as DB2, CICS, and WebSphere Application Server. TSO-E address spaces are created for every user who logs on to z/OS. Address spaces are created for every batch job that runs on z/OS. The chart is from an SDSF display of active address spaces sorted by ASID, address space ID. Observe ASID 1 * master * to ASID 25 SMF. Address spaces 1 to 25 are started as a result of the z/OS IPL, initial program load. Observe ASID 32 and ASID 35 are user address spaces. The purpose of the diagram to the right of the SDSF display is to point out that operating system pages will occupy common area available to the private user address spaces. In summary, you are better able to describe the management of operating system and application program address spaces. Thank you for your time.